The Marmon Industrial Energy Infrastructure Group, a division of Marmon Electrical, is the industry leader in power, control, and instrumentation cables for the nuclear, utility, oil and gas, manufacturing, rolling stock, and fire safety markets. With more than 100 years of experience supporting global energy markets, we are excited to offer world-class product solutions and the services to support the fast-charging cable needs for the EV market. This experience and expertise uniquely position Marmon IEI as a key U.S.-based supplier in the EV DC fast-charging cable market. Our patent-pending forced air-cooled solution is an innovative game-changer. Innovators at Marmon IEI have developed a proven solution for forced air-cooled cables for EV charging stations and OEM manufacturers. This technological breakthrough can safely deliver improved uptime, reduced cost of ownership, and an enhanced user experience with greater cable flexibility. Without the use of liquids such as glycol, it is a more environmentally friendly charging cable. Welcome to the world's first successful demonstration of a forced air-cooled charging system. It is a lighter and flexible cable which provides reduced maintenance costs. This is the scroll air compressor.
We're going to begin with a scroll compressor. The purpose is to compress the air, and we're going to feed it over to this air tank. This is going to be the receptacle where we're going to hold that compressed air. Now, what's important in our system is that that air is very dry and it has no particulates or oil in it. So how do we do that? Well, we have desiccant dryers, and we also have filtering systems here that are making sure downstream compressed air is very, very clean.
This is the supercooler.
So I'm with Darren Zimmerman representing Copeland. Copeland is the supplier of the Marmon supercooler. Darren, why don't you tell us how this unit works?
Yes, hi, Joe. So basically we have the high and low side of a refrigeration system here. So we're taking your compressed air and it's being pushed through our heat exchanger, which we're supplying the refrigeration for, and we're going to cool that air, which will then be pushed through the charging cable to help cool the cable.
Excellent.
Engineered air couplers are attached to the two power conductors that allow the chilled air to flow through the cable insulation. The chilled air removes heat that is generated by the power conductors so the cable can operate safely and efficiently. Temperature sensors were attached along the length of the 7-meter cable assembly every 5 feet to measure outside jacket temperature during the charging test. This ensures safe user handling. One temperature sensor was placed on the connector vent to measure output air temperature. For this test, simple vents were placed on each side of the connector handle for air to evacuate. This equipment simulates the vehicle being charged. This is the battery emulator. The program allows us to set voltage and amperage per testing requirements. And this emulates this charging station, the other side of our charging simulation. Here we can see each component of our system. We are tracking data such as temperature, pressure, and airflow through each charging cycle test. Here is one of the tests during which we maintain under 60 degrees Celsius at 375 amps for 30 minutes. Back to our data acquisition screen, which shows a live charging cycle. As the high current creates tremendous heat, the supercooler is keeping the cable at a safe operating temperature using only air. We track this by monitoring the sensors we have placed along the length of the cable.
This is the new forced air solution that we are patenting. As you can see, the cable on the left, more copper, heavier, less flexible. Cable on the right is the forced air solution with the air channels around the conductors. It's lighter, more flexible, and uses less copper.
Contact us for more information at ev@marmoniei.com or call us at 1-800-327-7625.